Hey guys, what's up? So, in the last video, you saw me discussing about the LM35 basics, how to use the LM35, how to connect it with the Arduino, how to get readings out of it. So, similar to that video, here we'll be discussing another basic component, which is a real-time clock or an RTC in short. So, the component which we'll be handling in this video is called DS1307. Now, uh, as you might know, when you're dealing with Arduino, you might have already dealt with a few time functions like delays and millis. But what if you had to make a project in which you had to set off some particular event or some particular actuator or some particular sensor to perform its function at a set date or a set time? That time, of course, you cannot use delays on millis. It is rather crude way of performing the project. Uh, it's more preferable to rely on an RTC to do the work done. DS1307 has a few features which makes it a popular choice amongst hobbyists or DIY artists. First of all, it has a 12-hour or 24-hour format. Then you can also display the time. You can also display the year. Uh, to communicate with the RTC module, you can use the I2C serial two-wire serial interface. So that again works. You don't have to, you know, struggle with a lot of wires to get it communicating with the microcontroller board. Then again, its power consumption is pretty less. The total current drawn by the module is in the range of nanoamperes. So uh, whatever power source you are providing it, you can be rest assured that this whole model does not consume a lot of energy while maintaining its function. These RTCs also have a feature where even if you cut off the main power supply, it can still continue to retain the information of the time, and it can even display you that data at a later instant. How is it doing? Well, the concept of cutting the power off, the main power off, is not entirely true because you're still having an auxiliary power supply. In case of DS1307, you have a coin cell which is placed at its backside, and that's how the board is being powered even when the main power is cut off, and that's how it's able to retain its information. If we remove that power source also, then the RTC will lose that information, and next time when you use the RTC, you'll have to reset the time and date again. That is just to give you a rough idea of what this DS1307 is. It's better that we move on to some of the pin-out diagrams of what this RTC looks like, and some basic features also. So let's get on with it. So if you look at the RTC module, you can see that on both sides you have some pins repeated, pretty visible, like the DS, SCL, SDA, VCC, JND. They are also repeated on both left and right side of the module. This is commonly seen in almost all I2C modules, probably for the sake of convenience. But we can only use one side and still get the same functionality. The SCL and STA pins are necessary for the I2C two-wire serial interface, so that will be using for the communication purpose. The DS pin is used to enable or disable this module. Then VCC and GND, obviously power supply and ground. The BAT pin is the external power supply pin, so that if you have any external power source, you can power this module through that power source. So you do not have this coin cell at the back of your module to make the power supply possible.
Now let's talk about how we use this model along with the Arduino. Now, as you can see from the whiteboard example here, only 4 pins are required to be interfaced with the Arduino. That's the STL and SDA and SCL pins, sorry, for the I2C communication to happen. Then the obvious VCC and GND pins will be using for powering up the module, and this will be like the primary power source for the RTC. The SQ pin is not relevant, at least for this video. If you want, you guys just let me know whether you want me to make a separate video on it. I'll sure make one if the necessity is. But what I can tell you at most is that This pin is particularly used when you want to create a pulse train, or when you want to create different frequencies, like the ones which I mentioned, 1, 4, 8, or 32 kilohertz. Okay, so okay, now to use this RTC module, you require certain libraries which you can get it off of GitHub. On GitHub, there's a developer by the name Paul. He has created this library uh, on uh, on the GitHub page, which I'll be giving down obviously in the description. You can download the code. Let's go down over here and download the zip file. Then you'll have to install this zip file into your Arduino IDE. So once you are in your Arduino IDE, go to Sketch, go to Include Library, and add zip library. See, after you do this step, this window will appear. From here, you select the downloaded zip file and press open. I've already done this step, so I'll skip off this one. Okay. Once you are done installing this library, then you can open up the examples, and over here you will see DS1307 RTC done. These are some custom libraries. So among them, we have the 1307 libraries available. Under that, you have two examples. One is to read the time of the RTC, that's the read test, and one more is to set the time on the RTC. Now, RTC will not have the time initially set up on it. It will be initialized to 00, like 0 hours, 0 minutes, 0 second kind of thing. So, to get the time on the RTC right, to set it to the right time as the current date and current time, you need to use this example, set time. So, when you come over here, this is the code. I will not go too deep into the code. Uh, but let me just explain you some, some important aspects which you need to keep in mind. One is the inclusion of wire.h library. This is necessary for carrying out the I2C initialization or the I2C communication protocol. Then timelib and DS1307 RTC. These are necessary for carrying out the RTC functions. Sometimes when you're running the code, you might run into the issue that timelib library is not there. So if that's the case, then go to library manager, then search timelib over here, then you install it. After that, you will not get such errors. Another important aspect of this code is mainly found in the loop function. So over here, you have get time and get date. So as the name suggests, you're getting the time and you're getting the date. Okay, and what time and what date are you getting? This macro. So what this line is doing over here is that it is reading of the date and time which is present on your system. So if your system is showing say 1732 and date as say 27th April, this is what will be reflected over here. So using the structure TM elements, you create an instance of it, TM, and onto it you store this data, date and time, and then you write this data onto the RTC. You set it. There are some serial print statements so that we can know whether the date has been successfully configured or not. Then yes, that's the basics. So now I have made the connections as I shown in the whiteboard example. Now let me connect the Arduino. So yes, the Arduino is set. Now let's upload the code. Uploading is done. Now let's see. Yes. So the RTC model has been configured now with this time and this date. So now, say I disconnected the Arduino from the RTC. The information about the date time now will not be erased of this module because it's been powered by an auxiliary power source, that is the button cell placed behind it. Even when you disable the device using the DS pin, even then the module is able to retain the date and time information. Now this is about storing the current time and date onto RTC. Now, say you have an RTC which has already configured. Now you want to read off the time and date set on it. How do you do it? Well, it's simple. Come out to files. There's another example which I just showed you, which is set time. Sorry, I mean read test. Read test. So go to read test. Under read test, you'll have this code available. So here you have the print statements, necessary print statements. Uh, Print two digits. So this one might seem a bit unusual for you, but this is simply to set single digit numbers. Like say you have 1 second, 2 seconds. So instead of displaying them directly as uh, 1 second or 2 seconds, you are displaying 0 1 second, 0 2 seconds. For that, you write this code. The rest of the code is pretty much understandable, I believe. Okay, so now let's upload this code. Let's open our serial monitor. Yes, as you can see, we are getting off the reading of time and date. Now this is just using the serial monitor. That's why you're using serial print. If you had another, dedicated display, like say an OLED display or a 16 by 2 LCD display, you can include all the relevant libraries and also perform the same function of displaying the date time over there as well.
Okay, so now you know how to set up the RTC module. Now you know how to write the code for it, and also how to read the time of the module. Right now, coming to applications, I'll be mentioning very basic ones. So first of all, obviously, to read of time and date, you can make something like a clock using a 16 by 2 LCD or a OLED display, and we can use some relevant libraries to display this in some neat format. You can also make something like a reminder project. So you write particular tasks, you assign certain times to it, and on that particular time, you should be given some sort of indication, say an LED reminder or some buzzer reminder or something which alerts you that this task is pending or this task is to be achieved in this duration of time. So that is just one example. Again, like I said, you can create something better also. The two parts, LM35 and DS1307, which I have covered so far. If you have any other component in mind which you want me to cover or which you want to learn along with me, then please let me know in the comments so that I can do a bit of research and come up with a new video so that even you can learn something from it. So, yeah, until then, I hope you guys have a great time. Have fun experimenting, have fun fiddling with the different electronics out there. This is Srihari signing off. Bye.